So today, I'm going to explain about knowledge base RS, knowledge base recommender system. We are going to learn some concept about the knowledge base recommendation system or knowledge base recommender system. So first, we are going to learn more about what is constraint base. So there are some concepts on the constraint base, like constraint satisfaction problem. We have another concept like conjunctive query, interacting with RS, and we will look at the default of knowledge base, such as static, dependent, or derived knowledge. And there are some concept about unsatisfied requirement. So, for example, what is the meaning by relaxation, prepare, and ranking? And there is also another kind of knowledge base, which is case space. So we will take a look about similarity measurement and about critic. So critics can be about single critic, compound critic, and dynamic critic. And we will see one application for the knowledge base recommender system. So until now, you already learn many things about recommender system. The most popular approach is collaborative filtering. The collaborative filterings, people mention it as memory base and model base. So if it is about memory base, we know that we will look at the similarity, maybe the similarity between users or the similarity between items, and we can do recommendation. For the model base, we will create a model. So the model can be anything. For example, we can use association rule. We can use naive bias. We can use decision tree and so on. And we can do the recommendation. For content base, we already learned about the TF-IDF or how we leverage the content for the item. How can we leverage the content about user? And finally, we can make the recommendation. And last week we learned about hybrid. So in the hybrid, there are three concepts. We can learn about the ensemble. So the ensemble is the same with the parallel. And we learn also about the monolithic. Monolithic means we are creating a feature. So we can combine the features, we can augment the features, and also mix. So mix means hybrid. We can do a combination, or yeah, we can have the sequential and so on. So today we are going to learn about knowledge space. So in the knowledge space, there are two concepts, as I mentioned to you. We can use the constraint base, and the other we can use case space. So in the knowledge space, in the constraint base, we are going to use the knowledge, and then we may have some constraint before we do the recommendation. And for case base, we are looking at the similarity, and we can do the recommendation among the feedback from the users. So so you already know about this diagram before. When we want to use the user profile and some contextual parameters, then we say this is content base. And if you want to use some community data, in this case, the community data is the rating, then we call this is the collaborative filtering. If we have the product features, then we can combine with the content base. Now we will look at the knowledge model. If we combine everything, if we combine everything here, then we can have a recommendation component before we produce the recommendation list. So in the collaborative, the question will be something like this. Tell me what's popular among my peers. In the content base, the question will be something like this. Show me more of the same what I've liked. And for the knowledge base, it's more about tell me what fits based on my needs. So we want to look at the user needs. User needs mean what the user want, what the user requirement until the user satisfied. So why do we need knowledge-based recommendation? Sometimes products with low number of available ratings. Let's say you want to buy a luxury house. So this is very expensive luxury house or expensive house. Maybe this is only for rich people. Okay. And there is no rating because yeah, maybe who the person who buy this kind of house is only one or two. Okay. No, not so many people want to buy this kind of house. Let's say this item, this car. This is very expensive car, and people maybe only a few people want to buy this car, and the rating is not available. The other kind of reason, time spent. So the time spent, we call this is time spent because there is a kind of horizon or period. Let's say I want to buy computers, but the computers, the rating of the computers is already 5 year old. So now is 2024. And the rating, it was produced on 2018. So do you trust this rating? It's maybe very old-fashioned computer. So we cannot trust it. And user lifestyle or family situation change. Okay. So in 2018, you still do not have children. But in 2024, now you have children. So you want to make let's say you want to buy a good computer. You want to buy a tablet, which is more uh, fancy or is more advanced in technology. Then there are some changes. And also customers want to define their requirement explicitly. So let's say I want to buy a car that the color is black. So in Korea, yeah, they have a high requirement for color on car. So they want to specifically maybe white or black. So it's the customer requirement. Then based on this reason, the recommender system provide the knowledge-based recommender system. So they have the concept. The first is constraint based. So the constraint based means it is based on the explicitly defined set of recommendation rules. So we have rules. And we will try to fulfill the recommendation rules. So fulfill means we try to satisfy. Okay. And we satisfy the recommendation rules. The other kind of knowledge-based recommender system, we call it case-based. Case. So it's like example, or one case means one product. One case is one item. So it is based on the different types of similarity measures. So we can give a similarity measures, and then we can use that measures to recommend. So retrieve items that are similar to specified requirements. If we have an item, if we already retrieve the items, then we will take a look. How big is the similarity? So both approaches means the case-based and the constraint-based. They are similar in their conversational recommendation process. You know, conversational. So it means we want to do some kind of chatting. Do you like this price? No. Okay, then, okay, I will give you another product. Do you like this product? No. Then I can give another product. Do you like this color? No. Then I can give another product. So it's like conversation. And the conversation will need to specify the user requirement. User specify the requirement. Okay, I want to buy the camera with the black color. I want to buy the camera with 25 megapixel and so on. And the systems try to identify the solutions. If no solution can be found, then user should change the requirement. So this is like the process of the conversational. So if you look at this one, in the constraint-based recommender system, there are three. There are three kind of concepts. First, we can look at the knowledge base. For the knowledge base means we will ask the user. So what is your requirement? Okay, the requirement is the price should be lower than 300 euro. Okay, this is one requirement. And the other requirement, the camera should be suited for sports photography. Okay, so the users have a very specific requirement, and because this is the knowledge. Now the store or the maybe the vendor, they need to look at the constraint. Is there any product that fit with this requirement? So they will check the item variable. The other concept or the other method, we call it constraint satisfaction problem. So we have some variables, and then we have domains, and then check whether the constraint is fitted with the requirement or not, and then how it is satisfied. The other kind of recommender system, we call it conjunctive query. So the conjunctive query, we can use some SQL. We can use SQL to check whether the requirement can be satisfied with the information in the database. So we have C. C is the conjunction of equality condition. So this is a condition, and the condition you can define. For example, here the TJ, the TIA equals to TJB, and then the T1A equals to the condition C. So this is the query. Maybe I will not discuss in detail for this one. So let's just look at the knowledge base and the constraint satisfaction problem. So knowledge base. So what is knowledge base? As I mentioned to you, we have the user requirement. we want to ask the user what would be your requirement about the features, or we call this is the model features. And we will look at the item variables or the item properties. And this is the mediation. Mediation means we want to compare the user features and the properties of the item. So the user model features, which is the requirement, we will look at the catalog. The catalog is the item properties variable. The idea is simple. We can just use the if function. So a set of constraints, for example, using the if then else. So if the user requires A, then give the item that possess feature B. And we can have this one as the hard or soft weighted constraint. So hard constraint means, let's say, I want to have the item cost equal to 300 euro. So it means I have 300 euro, so I want to spend it. Or I want to have a relax or soft constraint. So the item should be less than or equal to 300. So it is less hard. So it is not hard, but it is soft constraint. And we will have some solution preferences. Solution preferences means we have not only one, but it can be more than one preferences. This is example that I mentioned before. The price should be lower than 300 euro. Okay, if you look at this product, if the price should be lower than 300 euro, then this item, this item, this item, this, 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 and this. Okay, so every product can be recommended. But now the camera should be suited for sports photography. And what is the good item for the recommendation? So in this case, yeah, we need to ask more the specific requirements. For example, do you have any information about the megapixel? Because we don't have the variable whether it is related to sports or not. But we have knowledge. Sports require speed. So speed means maybe the megapixel should be high. Or the sport should require some optical zoom. So if the zoom is high, then it is good. And the sports require a good LCD size. And maybe we also need the movie. About the sound, maybe it is not necessary. Waterproof, maybe it is, yeah, sometimes it may be good, maybe it is also not necessary. So yeah, it's very diverse for this requirement. Then yeah, we can have another requirement. For example, we can do the constraint satisfaction problem. So what does it mean by constraint satisfaction problem? This is theory in optimization. We can apply the constraint, or we call usually the CSP, constraint satisfaction problem. We have xi and we have xu. So xi, it means a variable describing the product or item, and xu, it is the variable describing the user model with the domain D. And then we have the SRS, which is the specific requirement of users. For example, yeah, we have the purpose. Okay, the purpose of buying the product is for traveling. And we have the KB, or the knowledge base. The knowledge base is something rules about the domain. Let's say if the purpose is on travel, then lower focal length should be lower than 28 millimeter. So this is the knowledge. And you need to get those knowledge before you do the recommender system. And I is the product catalog. So the CSP means we want to satisfy this requirement, because this is the knowledge base RS with declarative knowledge representation. It is the combination of the variables for items, the variable from users in the particular domain. So in the particular domain means it depends on the product. If it is camera, then the constraint satisfaction problem will be about the camera. If it is about car, then the constraint satisfaction problem will be about car, and etc. So as SRS, KB, and I, it is the combination of the requirement, knowledge base, and the product catalog. The solution will be, what is the tuple? You know tuple? Tuple. So it means one instance. Tuple is one row, or tuple is one example. In this case, this is one tuple. This is another tuple. This is another tuple. And we want to assign a tuple to the tuple. So there exists of X such that the Xi means the item, it fits with the user requirement V in the store, it means in the database, and V is in the domain of X. So V is one. It is in the domain of X. Let's say the domain is camera, then yeah, it fits with the camera variable, and this is satisfiable. So we have this kind of constraint. ST means subject to. ST means subject to. Subject to, the SRS is the specific requirement for user, KB is the knowledge base, and I is the product catalog, and theta is the tuple. The tuple means one row. If we have a row that can be assigned to this requirement, then it is satisfiable. Now, let's take a look. With the constraint satisfaction problem, we have the compatibility constraint. What is compatibility constraint? So the compatibility constraint means it allows the instantiation of customer properties. For example, if large size photo prints are required, then the maximal acceptance price must be higher than 200. So this is the compatibility. Okay, we know if we want to buy a camera, let's say, okay, I have with high pixel. And of course, you know, high pixel camera should be expensive. So that's the compatibility constraint. Okay. The same with this one. If I want to have a large size photo prints, then the price will be high. We have another kind of conditions. We call it filter conditions. The filter condition, it defines the relationship between customer properties and product properties. So we can make this kind of condition. Let's say if we want to have a large size photo prints, then the required resolution greater than 5 megapixel. So if it is less than 5 megapixel, maybe the quality of print is not good. So this kind of knowledge, you should have the database. And we need to have also the product constraint. The product constraint, it defines the currently available product assortment. An example constraint defining such a product assortment. Its conjunction in this constraint completely defines a product or item, and all product properties have a defined values. So yeah, you need to make something like these properties. The price. Okay. So you need to ask the user, please define the price. How much price do you want to allocate to buy the camera? Okay, the price will be from 0. So 0 is minimum. So it means, yeah, the user will not buy anything. But usually the user will just say, okay, I can buy until 500 euro. Then the price will be in between 0 until, like, say 1000. And you can define the usage. For example, okay, the usage is only for the digital, or the usage I want to print it later just for small print. I want to print the result later for large print. Or I want to have a photography which is about sports. So I want to just use the camera for landscape. Or I want to use the camera for portrait. Or I want to use the camera for macro. You know macro? Usually we want to use the macro for showing a very detailed product. Like I want to show a flower. So the flower can be zoomed in very detail. So the quality should be very good. Okay. Then this is the customer properties. What about the product properties? Okay, the product properties, we have the price. It is in between 0 until 1000. And then the MPix is the megapixel. We have the camera from 3 until 12 megapixel. This is just example. And the camera will have the optical zooms between 4 until 12. The LCD size, it is in between 2.5 until 3. The movies means whether the camera can support movie or not. Sound, whether the camera can save the sound or not. Waterproof, whether the camera is waterproof or not. So this is the product properties. Now, in the constraint satisfaction problem, we want to look at the customer properties and the product properties. Yeah, we can use a kind of query. Okay, so the one that I showed you before, it is the conjunctive query with the SQL database, but I will not use the SQL database in this case. So let's just look at how we can do the query with just simple condition. So the conjunctive query, it is different with the constraint satisfaction problem. It is different from the constraint solver. In this case, yeah, it is not to find valid instantiation for CSV. So we don't need to do the constraint satisfaction problem in this case. We just do the query. So it means we just look at the condition and then we extract from catalog, or we extract from database. So the database means something that you already have in maybe a MySQL or SQL server. And then the conjunctive query is executed in the item catalog. We have a set of selection criteria that are connected conjunctively. So conjunctively means one constraint and then followed by another constraint and followed by another constraint and so on. So let's say I have the top, this is top, and I just define the criteria. So the criteria will be based on the product that you want to look at. P is the product assortment. And then let's say, what is the criteria? Okay, the criteria, I would like to look at the product where the megapixel is higher than 10 and the price is lower than 300. So this is the conjunctive query. And we will look at the instance. The megapixel is higher than 10. Not this one, not this one, not this one. Okay, we have one. Not this one, not this one. Okay, we have two and not this one. So we have two product, which is P4 and P7. And we will look at the price. The price should be lower than 300. Okay, this is lower than 300. Okay, because the criteria is suitable or the criteria is satisfied, then we have P4 and P7 as the recommended product. So this is the conjunctive query. We just use the simple if. The interaction with the constraint-based recommender system means we need to have the specification from the user. So let's say if you go to maybe Electromart or if you go to Lotte Mart, Highmart, and if you want to buy something, then the storekeeper will ask you, what do you want? Do you have something that you want to ask and etc. So it means we need to have our specification. We can have everything all at once. Maybe you already have the notes. Okay, want to have a camera which is lower than Ibec Manon, and then I want to have a megapixel as 25 megapixel, and the storage can be blah 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 blah. So all at once. But sometimes we need to have the idea incrementally. Incrementally means, can I have a camera which is less than Ibec Manon? Okay, then after you know the products, maybe you will look at details. Can I have camera with a good video? Okay, this is the camera with good video. And then next, you will have another requirement. So it is incrementally, one by one. Or it is interactive dialogue. So interactive dialogue means you will ask about the details. Can I have the camera with the price less than Ibec Manon? Okay, this is the camera. So maybe you will ask, what is the good things about this camera? Okay, then there will be some details about this product. So this is the interactive dialogue. So the user is presented with a set of matching items. Let's say we want to ask the user with explanation to why a certain item was recommended. The user might revise his or her requirement to see the alternative solution and narrow down the number of matching items. For example, if you want to buy a smartphone, maybe once you go to the store, you want to buy a good smartphone, but the good smartphone is very expensive, and you may have the revision. You may revise the requirement. Okay, I want to buy a cheaper product. So we will look at the alternative solution. Or okay, if I want to buy at the first time, I want to buy a smartphone with pen, but it is so expensive. So okay, maybe I need to give up the pen. So it is narrow down the number of matching items to fit with the requirement. So some examples. If you look at the online shop, for example, you can have the all at once constraint. All at once constraint means you can see everything. And then the constraint, if you look at, for example, in this website, Coupang, you can see the constraint in the left panel. So once you click, and then you can see the result. And the list of product will appear. Or we can have the incrementally. Incrementally means one by one. For example, now I want to see the frequency of a product for weekly. And then after I know weekly, then I want to specify what is the day. Let's say I want to specify only Thursday. And then after I know Thursday, I want to specify a particular date or a particular time. Okay. Then this is incremental, one by one, step by step. Or yeah, we can have the interactive dialogue. So in the interactive dialogue means first I want to know the intent. Intent. So this is a very good topic. Now I think you already have the topic for your project. Intent is a new topic and it's very good to know. I want to know the intention. Intention. I don't know what is the Korean of intention, but there is a word intent detection, intent recognition. With the user specification, we can know what is the intention of users. And then because we know the intention of the user, then the dialogue can be suited for this intent recognition. And it follows with this intent. For example, I can see the entity, what are the entity that fits with this intent. I can see the sentiment of this intent. I can have another thing. So it's like chatting. And at the end, it will be a recommender system. In the constraint-based recommender system, we will have default. Default or jujur. Okay. Support customers to choose a reasonable alternative. So let's say when you go to a website, you want to buy a laptop, but you do not know what is the criteria of the good laptop now. So you're not unsure about which option to select. And you don't know the technical details. So some people, if they are not familiar with laptop, it is difficult. So they just want to know what is the good laptop for study, what is good laptop for doing experiment with high or big data. So there will be several kind of defaults. Okay, if it is static defaults, means for everyone it is the same. Or we will have dependent defaults. So the default is depending on some variables or the derived default. The default is derived from one variable. We can have the next question or selecting the next question. Most users are not interested in specifying value for all properties. You know what does it mean? So if you go to a store, you may not give the details. So what is the camera you want? So you will say, I want a good camera. But you will not say, I want a camera with 25 megapixels. So you can specify the correct numbers. You will just specify, I want to have a very advanced camera. I want to have a very good camera. So specifying value is not the interest. And identify properties that might be interesting for users. Oh, now the camera can be, uh, we can change our face to an avatar. Okay, that's something interesting. So now the camera can change the background. Okay, that's something interesting. So the users wants to know that kind of properties that is interesting for the user, but it may not be about the product. It may not be about the zoom. It is not about the waterproof. It is not about the movie and etc. So the default is something that we for the store manager. It is necessary because if you don't have the default, you may be very uh, confusing how to recommend the items to the users. So the defaults are are an important means. The defaults are important means to support customer requirements specification process, especially in situations in which they are unsure about which option to select or simply do not know the technical details. So if someone who do not know about car, okay, we can recommend, then just buy Gibbon or Gijon car, the default car. If you want to have some option, okay, you can have some more option. So it can support a customer to choose a reasonable alternative. So if a customer is interested in printing large format picture from digital images, the camera should support a resolution of more than 5 megapixel. So maybe this is the default. So if you can define the default, then it is good for the customer because it is not easy to define the value. But the negative is it can be abused to manipulate consumer to choose certain properties. What does it mean? For example, okay, this is an example. User can be stimulated to buy an LCD display control panel functionality in a car by presenting the corresponding default value. So for example, one senior or old people, they want to buy a car. And by default, now cars have the display, the LCD display. However, for the old people, it is not easy if they use the LCD. But now car has already the display or LCD display. Then yeah, we can say it is a kind of abuse. It is offer from the user expectation. So that's the negative of the default. So as I mentioned to you, there will be static default, dependent default, and derived default. So the static default means one default is specified per customer property. So one default. For example, if the default usage is for large print, then typically users want to generate poster from high quality pictures. There's another default, we call it dependent default. A dependent default means a default is defined on different combination of potential customer requirements. So the default will be about the usage. The usage is small print. Okay, it means every users, we assume that they want small print. And if it is small print, then the maximum price will be 300. So that's the dependent default. Because we have this condition, then the maximum price will not be more than 300. Derived default means when the first two default types are strictly based on the declarative approach. So this is declarative. This is declarative. The third type exploits existing interaction logs for the automated derivation of the default values. So for example, if the default value, if we have the optical zoom is 10 times, then of course we know that the LCD size will be also high. So it is the multiple attributes derivation. Okay, let's take a break. Okay, I'll continue after the break.